So, hello, my name is Chef Akila from IF Science. Now, today I want to tell you the integral test, direct and limit comparison test, ratio, and root test. So, before we do that, I prepare the question. So, as you can see here, we got a number 4. So, that's sigma plus negative n is equal to 1, 2 over Tn plus 5. So, what do we do? The first thing first, we need to write the nth term as a function. So, this will be, the question will be fx is equal to 2 over Tx plus 5. And then after that, we need to, since the function fx is positive, continuous, and increasing for x greater than or equal to 1, use the integral test. So it will be integral of plus infinity of the 1 to the infinity 2 over 3x plus 5 is equal to limit a plus infinity. To evaluate improper integral, by definition, we need to divide it using limit and a definite integral. So limit will be limit a to the plus unity in the bracket a equal 1 2 over x plus 5 dx, and then to evaluate the definite integral. So the integral will be limit a to the plus infinity in the bracket 2 over 3 times ln in bracket absolute 3a plus 5 minus 2 ln in bracket 2 cross bracket. Alright, so it will be since the limit is plus infinity, the improper integral diverge, so it will be divergent. Alright, we move to the next number, and I will prepare first for the question. Alright, so we need to go to the direct and limit comparison test. Number 6, we need to use direct and limit, so we just need to direct. Okay, so as you can see in here, number 6, we have plus infinity sigma n is equal to 1 over 3n squared plus 2. So for the comparison test, compare the series term by term with the series 1 over 3n squared. So we need to compare it. So it's 1 over 3n squared plus 2 is less than 1 over 3n squared. Since the is converged, then the given set also converged. So that's it. And for the next step, we need to using limit. So yep. And here we need to write the equation again. That plus infinity sigma n is equal to 1 over 3n squared plus 2. In here, we need to define the Bn. For limit completion test, we need to use convergence series. So it's based on the square that figure. So it's Bn is 1 over n squared. Now we need to plug it into this. So the equation will be limit n to the plus infinity in the bracket 1 over 3n squared plus 2 over 1 per 1 over n squared. So we need to simplify it and then yep, simplify the construction. So we limit n to the plus infinity n in the bracket n squared over 3n squared plus 2. And then after that, we have to factor out the n squared from this equation. So it will be limit n to the plus infinity n squared over n squared times 3 plus 2 over n squared in bracket. So we need to evaluate it. So we need to erase the n squared in the denominator and denominator and then and denominator. So we have the equation will be limit n to the infinity is 1 in bracket 1 over 3 plus 2 over n squared. Then we need to evaluate limit, so it will be 1 over 3 plus 2 times 0. So it will be 1 over 3. So it's a converse because limit is this. Alright. That's for number 6. Let's move to the number 18. Ratio and root test. So in the ratio test, we need to evaluate the limit. For example, we have a limit n. We have a limit n to the infinity an plus 1 over an. So in this equation, need to apply it. So we will limit n to the infinity 5 over 4n plus 1 plus 1 over 5 over 4n plus 1. So limit will be limit n to the infinity 4n plus 1 over 4n plus 1 plus 1. Alright. So to that in it, both the denominator and the denominator are positive or 0 or 5 greater than n is equal to 1. So remove the absolute variable in this case. And we need to simplify the fraction. And then after that, we need to factor out the 4n plus 1 from the expression. So it will be like, so the answer will be 4n plus 1 times 1 over 4 plus 1 over 4n plus 1 over 4n minus 1 times in the bracket 1 plus 1 over 4n plus 1. In the end, we need to reduce the fraction into this part, so it will be limit n plus infinity in the bracket 1 over 4 plus 2 over 4n plus 1 over 1 plus 1 over 4n plus 1. So the equation will result a 1 over 4 plus 0 over 1 plus 0, so it will be 1 over 4. Since the limit is exists, it's converge. That's okay. So for the last step, we need to use root test. Root test. The second. So the root test, as you can see here, to use the root test, evaluate the limit And then after that, we need to expression inside the absolute value is positive or 0 for values greater than n is equal to 1. So we need to remove the absolute value bars. And then after that, to take root of fraction, take the root of the numerator and the denominator separately. So we just need to, yep, that's like this. The equation will be like a limit and to the infinity in the bracket and the square root of 5 over limit n to the infinity in bracket and over sorry, square root of 4 n plus 1. So it will be so to the need to use limit a is equal to 1 a is greater than 0 to evaluate the common limit. So the equation will be 1 limit n plus infinity e ln n over square root of 4n plus 1 the first bracket. So in the end we have this equation. After that we need to calculate and transform the expression using orbital and so on. So we got this equation, so it will be 1 over limit n to the infinity then 4 times 4n over 4n plus 1 over 1. So to that we need to wait a second. So we need to use the we use the commutative property to reorder the terms. So and then we need to so the equation will be 1 over limit e sorry 4 over e limit n to the infinity in the bracket 4 ln 2 times square over 2 ln 2. So in the end, it will be method followed limit. So limit will be 1 over e and plus to the plus infinity. Then the bracket 2 ln bracket 2 is equal to 1 over e 2 ln 2. So in this simplify the e 2 ln 2 into 1 over 4. So the limit is exists, so it's converged. All right, I think that's from me. Thank you for uh, thank you for your attention and see you on the next problem solving. Thank you.